All right, Algebra 2 here is part 6 of Module 3, and for the last video, we are graphing some quadratics here. We're solving, it was like we've already done that before. We're solving these by graphing. Strongly encourage you to do this for any of them on your test. Keep in mind, we cannot see how you're solving your equations. It's all multiple choice. All right, I'm going to graph this side here. I'm going to see where is it equal to this side. So on this side, it's a regular parabola that's centered at not negative 1, 3, but positive 1, 3. So we're up here. Regular parabola means if I go over 1, it goes up 1. If I go over 2, I'm going to square 2, so it's going to go up 4. And if I went over 3, it would go up 9. Whoops. Oops, if you graph it correctly, Miss Harris. There we go. All right, and I want to know, where does that graph intersect with y equals 7, which is this line? And those two intersection points are negative 1, 7, and 3, 7. So the two x values that would solve this is x is equal to negative 1, x is equal to 3. All right, same thing with number 29. We know y is equal to negative 3, so this is where we're trying to intersect with. And our graph is centered at negative 2, negative 3, so negative 2, negative 3. Aren't we lucky? And then it goes up somewhere from here, right? Doesn't look exactly like that. I guess you shouldn't be so lackadaisical. This is your review after all. For me, I'm like, oh, I see it hits it in one spot, so my one answer is x is equal to negative 2. If I want to make the graph look pretty, I'm going to go up 1 over 2. Let's see if we can make that look a little better. It'll look something like that, but this is the point we're interested in, where those two lines intersect each other. All right, number 30, solve each of the following quadratic inequalities. Write your answer in interval notation. So if I'm going to solve this guy, I first want to figure out where is it equal to 0. So I'm going to first set this guy equal to 0 and find what are called my critical values. So where are the points where my equation is equal to 0? And then from there I can figure out which sides is it going to be greater than 0. So first I'm going to divide this guy by negative 1. I don't like that negative sign, so I'm going to make it positive 2x squared. In other words, I'm going to multiply the whole equation by negative 1. And 1 times negative 2 is 2x squared. Negative 1 times negative 9 is 9x. Negative 1 times 5 is negative 5. 0 times anything is still 0. All right? I only have two factors for 2. Let's see if we can't factor this. So 2x squared has to be 2x and x. My only factors for 5 are 5 and 1. So if I go 5 here and 1 here, I'm going to subtract, and I need to get to 9. So 2 times 5 is positive 10x minus 1x. So 10 minus 1 is 9. Negative 1 times 5 is negative 5. I've got my signs right. Once I've got it factored, I'm going to set them each equal to 0 and solve. So I've got x is equal to negative 5, 2x is equal to 1, x is equal to 1/2. So on my number line, I've got negative 5 and 1/2. And I'm going to test the points in between to see if it makes a true statement or a false statement to figure out where it's above, where it's greater than or equal to 0. This is where they're equal to 0. And I need to find what are the intervals that make it greater than or equal to 0. So let's test a number greater than 1/2. Let's say 1. So for 1, I've got negative 2 times 1 squared minus 9 times 1 plus 5. Is that greater than or equal to 0? This would be 1 squared is 1 times negative 2 is negative 2 minus 9 plus 5. Negative 11 plus 5 is not greater than 0. So this is, that's not where we started, Miss Harris. This part here is false, so not in my solution. All right, a number between negative 5 and 1/2, the easiest one to do between positive and negative is 0. Notice that it's going to make this 0, it's going to make this piece 0, and I just have positive 5. Is 5 greater than or equal to 0? Yep. So chances are, if you think about it, we've got a parabola that's opening down. We've got two places where it's crossing the x-axis. And we know it works well in here, so chances are this is going to be a negative as well, but let's just plug it in to make sure. Plugging in a negative 6, which is just the next number less than negative 5. So this would be 2 times 36. Negative 2 times 36 is negative 72. Negative 9 times negative 6 is plus 54 plus 5. 54 plus 5 is 59. Negative 72 is bigger, so this is going to be a negative number. So my solution set is this here. From negative 5 to 1/2. This piece in here is the solution where this quadratic is greater than or equal to 0. All right, number 11, same thing, except for I need to set it equal to 0 first to solve it. First, I'm going to move that 5 over, and then we want to find the critical points from this guy here. Again, I'm going to divide by the negative sign. Woo! Helps if you actually change all of your signs there. My two factors for 3 are 3 and 1. My two factors are 5 and 1. I'm trying to get to negative 2, so if I've got 5 minus, 5 minus 3, let's see. This would be 5x, 3x. I want it to be negative 2, so I'm going to make it negative 5, positive 3. Check it. So negative 5x plus 3x is negative 2x. Negative 5 times 1 is negative 5, so that works. So then we're going to solve it from here to find our critical values. So one of them is going to be 5/3, which is 1 and 2/3. The other one is going to be negative 1. All right, put those guys on a number line. Here's negative 1. Here's 5/3, and then we're going to test our values. We are equal to, so we're equal to 0 at these guys. We want to include them. The easiest one to test is the one in between negative and positive, which is 0. If this guy was 0 and this guy was 0, I'd have 5 is less than or equal to 0. Is that true? No. So most likely these two are going to be false, but let's check just to make sure. What's a number less than negative 1? Let's put in negative 2. Is this guy less than or equal to 2? Negative 2 times negative 2 is 4, times negative 3 is negative 12. 2 times negative 2 is negative 4 plus 5. So negative 16 plus 5 is definitely less than or equal to 0, so this is good. And then if we plug in something, let's see, something bigger than 1 and 2/3, the next biggest one would be positive 2. Notice how this guy doesn't change, it's still negative 12, and then 2 times 2 is positive 4, but negative 12 is still bigger than 4 plus 5, which is 9. So this is still negative, and this piece is true. So what is my solution set? It's this piece here and this piece here. So from negative infinity to negative 1, and from 5/3 to infinity. Notice they wanted it less than or equal to, so we're going to include these endpoints of these critical values here. All right, that's it for your quadratics. These last two problems probably solved a little bit differently than you saw in class. That's more of a pre-calculus prep of where you're going to go next year. But hopefully you were able to follow along. I can't remember if you had one like that on your final, but maybe.